Okay, so here's the circuit I'm going to solve for by using the concepts we learned from chapter 11. So first I'm going to solve for K, the coupling coefficient. And second, I'm going to solve for the V0. And third, I'm going to solve for the energy stored in this circuit. So K is pretty simple. We just plug in the formula, which is K equals to N divided by square root L1, L2, which is 1 divided by 4 times 2. And we can get approximately 0.35. So that's the first one. So second one, I'm going to solve for V0. Okay, so first we need to modify the circuits by adding two dependent sources here. So the direction of the voltage source, the dependent source, depends on the dot. If this dot is on the top, so the positive side is on the top of this dependent source, and this dot is on the bottom. So the dependent source's positive side is on the bottom. So we learn from that the omega here is 4, so we can get all the impedance for the components. And we also can see from here the 1 ohm resistor is in parallel with this capacitor, so we got an equivalent impedance here. And then we need to apply the mesh analysis by using KVL. So for the left loop is minus 12 plus 2 plus J16 I1 plus J4 I2 equals 0. You can simplify this to 1 plus J8 I1 plus J2 I2 equals 6. And for the right loop is J8 plus 0.5 minus J0.5 I2 plus J4 I1 plus 1 equals 0, because there's a DC source here, which is 1 volt. And we just need to solve the equations, and we get I1 equals 1.51 minus 148 degree, and in the time domain is 1.51 cosine 40 minus 148 degree amp, and I2 is 0.6 100 degree equals 0.6 cosine 40 plus 100 degree. Yeah. So V0 is just by using the Ohm's law. So we just V0 equals I2 times the impedance here times Z equals 0.6 100 times J equals 0.43 cosine 40 plus 55 degree volts. That's the second one. And third one, I need to solve the energy stored in this circuit. So the formula for the energy is 1/2 L1 I1 squared plus 1/2 L2 I2 squared plus N times I1 and I2. So by the way, when time equals to 2. So here's the I1 and I2. I need to plug in T when T equals to 2. But here's one thing we need to mention. So 4 times 2 is 8, but this 8 is in red. So I need to convert 2 degree, which is 98.37 degree. Yeah, so I just need to plug in I1 and I2 when T equals to 2 to find the current at that specific time. So I1 equals to 1.07 amp, and I2 equals to minus 0.6 amp. Yeah. So after plugging the formula, I got energy equals to 2.01 watts.